Okay guys, so this, just so you know, this is not the lesson that you're supposed to watch for lesson 2.8, but what this is this is a review lesson that will help you with lesson 2.8. So the purpose of this little review lesson is so that you guys will know how to solve problems like this, for instance. Now, if you don't know how to do a problem like this, then you should probably watch this little video. If you feel like you could handle a problem like this, then you should you could probably skip this and move right on into our lesson. Okay, but like I said, this is not your lesson, so you don't necessarily need to watch this unless you don't know how to solve problems like the ones I was telling you. So we're going to go through, we're going to gradually work you up to being able to solve problems like that, because you need to be able to do that to do today's lesson. Okay, so back in lesson 1.7, so you guys have your notes. Back in lesson 1.7, I provided you guys with this, so you still have it. Quite frankly, if I were you, I wouldn't even put this in your notebook under lesson 1.7. I would just put it somewhere up towards the front so you can always look at it, because we're constantly going to need to come back to this. Okay. Ideally, you guys are also taking the time to have memorized this unit circle. Once again, it's not going to go away. This is going to happen all the time where we keep coming back to this. So remember, there's that extra credit assignment where you guys can demonstrate your skill and speed at memorizing this thing. All right. So anyway, before I don't want to take too much more time talking about all the intro stuff, so let's jump in. Let's get to the point where you guys will know how to solve this problem here. Now, there's a lot of work that we have to do to get there, so I'm going to cover all my bases. But we'll work our way up to it. All right, so first of all, this is the unit circle. Cosine tells you the x values. Sine tells you the y values. The tangent values are the ones that are in these green boxes here. Okay. Cotangent is the reciprocal of tangent. Secant is the reciprocal of x. Cosecant is the reciprocal of y. Now, since secant is the reciprocal of x, technically you can also say that secant is the reciprocal of cosine. Or you can also, and since cosecant is the reciprocal of y, you can also say that technically cosecant is the reciprocal of sine, because y is sine and x is cosine. I think a nice little note to have added on here would be this as well, because this is going to come in handy later today. Since secant is the reciprocal of cosine, that means that cosine is the reciprocal of secant, and sine is the reciprocal of cosecant. And another one you might want to add on to this page is the fact that tangent is the reciprocal of cotangent. Those are some good notes that you might want to add to the bottom of this page that we already have. It could come in handy for solving the problems that we're going to be doing today. All right, so that's the unit circle, and that's what all that good stuff means. So now let's go ahead and solve some problems. Just real quick, we're going to start off with something a little bit simpler here. What if I gave you guys cosine of theta is equal to 1? Well, what this means is it's asking us what angle has an x value, yx, because, why am I saying it's an x value? Because it's cosine. What angle has an x value of 1? Okay, so let's look around in our unit circle, and we want to find where do we have an x value of 1? Well, there it is, and the angle that goes with that is 0, so the answer is 0. All right, let me throw in at you guys, if you want to practice this, sine of theta is equal to a half. Now, I just want to warn you guys, there's two answers to this, but if you want to pause the video and try it out, you can. So this is asking us one angle has a y value of a half. There are two places where we have a y value of a half, and the angles for those are here and here. So the answers are pi over 6 and 5 pi over 6. Okay? Let's do another one, tangent. What angle has a tangent value of -1? Well, tangent is the ones in the boxes here. So here's where tangent equals -1, here's where tangent equals -1, and the angles that go with that are 3 pi over 4 and 7 pi over 4. Okay, so very often you're going to get 2 answers for those types of questions. So that's how you do sine, cosine, and tangent, but now when you start dealing with cotangent, secant, and cosecant, it's a little bit stranger. So I'll do a cosecant here. How do we solve this one? Well, I had you guys write down a little fact earlier. And it's going to come in handy at this point. So what we learned is that cosecant is the reciprocal of y, which is basically the reciprocal of sine. So if I take the reciprocal on both sides, that's going to be the first thing I'm going to do, is I'm just going to take the reciprocal on both sides. Okay, so just flip them both over. Think of this as over 1 and then flip them both over. Why did I do that? Well, because now I can replace this with what it equals. Earlier, I had you guys write down what that equals. It equals sine. So, basically, cosine of theta equals -2 is the same thing as saying sine of theta equals -1/2. And so from here, we're looking for what angle has a y value of a -1/2. There are 2 places where that happens, and they are 7 pi over 6 and 11 pi over 6. Okay, so I'm going to give you guys one. Why don't you guys try this? Secant of theta is equal to radical 2. Go ahead and do that one for me. Secant of theta equals radical 2. Pause the video, see what you guys get. Well, hopefully you guys started off by doing reciprocal. So anytime you have one of these 3 down here, you're going to start off by doing reciprocals. So it's going to be 1 over secant is equal to 1 over radical 2. 1 over secant is cosine. Now something that wasn't on mine, but hopefully you remembered from the last time we worked on these, is we don't like having square roots on the bottom. So by doing this, we end up with radical 2 over 2. So really what this is cosine of theta equals radical 2 over 2. So now we're wondering what angle has an x value of radical 2 over 2? And that would be here and here, which is 4 pi over 4 and 7 pi over 4. Okay? Let's do one more. So pause the video if you need to try this problem. But see if you guys can figure out what the angle is for cotangent of theta is equal to negative radical 3 over 3. Well, since it's one of these 3, the first thing we have to do is flip it over, right? One over cotangent is tangent. We don't like square roots on the bottom. Radical 3 times radical 3 is 3. The 3's cancel, and so here's what I'm left with. So we're looking for tangent values of negative radical 3. That would be here and here, and the angles that go with those are 5 pi over 3 and 2 pi over 3. Okay?
Mr. Bailey.
So the last thing I want to talk about on this little review video is how to deal with arc trig functions. So remember, our goal was to be able to get you guys to be able to solve something like this. Okay, so that's our goal. But before we get there, I want to remind you of some basic stuff here. So first of all, for instance, if sine of theta equals y, that means arc sine of y equals theta, right? And that applies to all of these trig ratios. So the input becomes the output and vice versa when you're dealing with arc trig functions. The next thing I want to talk to you is about the range of possible answers. And this is also something that we've talked about a little bit earlier, is that for arc cosine, arc secant, arc cotangent, their answers are limited to the top half of the circle. And so you can only get one answer, and it has to come from the top of the circle from 0 to pi. And that applies to these three arc trig functions. For these three arc trig functions, you are restricted to choosing answers that are only on the right side of the circle. And as an extra added confusing bonus, in the bottom portion of this circle down here, you're not going to use the regular values that are on the unit circle. You're going to use the negative versions of their counterparts on the top. So your answers for arc sine, arc cosecant, arc tangent are from negative pi over 2 to positive pi over 2. Okay? So it's a little bit different when you're working with those things. So let me do one problem like that. So suppose I asked you guys to find, I'm going to go ahead and let me erase one of these sides over here just because I don't have enough writing space. So I won't use that one. I'll use the other side there. But suppose I gave you guys this. Suppose I said arc sine of radical 3 over 2. And I asked you to figure out what that was. Okay. Well, the first thing you're going to do is you say, well, we know that equals some kind of an angle. Now, for me, what I would do is I would start by rewriting this as the inverse instead. I like the angle in here and this out here. You may not need to do that step, but I find it helpful to do that. Now that I've rewritten it, I can see it's asking us what angle has a y value of radical 3 over 2, and that would be right there, so the angle is pi over 3. So the answer to this thing up here is pi over 3. Okay? So what I would encourage you guys to do is see if you, and by the way, there is another one, it's right here. That's another y value is radical 3 over 2. But remember, when you're dealing with arc sine, you're restricted to the right side of the graph only. So we cannot use that one. Okay? So let's back up a little bit. I want to throw in at you guys now. So how about this? What if I asked you guys to find arc tangent of negative radical 3. See if you guys can find arc tangent of negative radical 3. If you need to pause the video here, go ahead and do so. Well, we know it equals some angle, right? And we know Mr. Bailey likes to rewrite it in this fashion as a normal tangent rather than an arc tangent. And so now I'm just looking for what angle has a tangent value of negative radical 3, and that would be right here, and the angle is 5 pi over 3. Now you may have picked this one, but remember that when you're dealing with arc tangents, you are restricted to the right half of the graph only, and therefore this is not an option. You can't use that one. Okay? One more type of thing I want to make sure you guys know how to do, and this is kind of the granddaddy problem here. This is where it gets kind of ugliest. So suppose I asked you guys, find me arc cosecant of 2 radical 3 over 3. Okay. Well, for this one, we're going to start by making it equal theta. The next thing we're going to do is we're going to rewrite it as the normal cosecant function rather than as the arc cosecant function. We don't like these. Anytime we have those three, we do the reciprocals. Oops. We do the reciprocal on both sides. We replace that with what it's equivalent to, which is sine. And here we need to rationalize. So these two things put together make 3, and that cancels with that 3. So I'm left with radical 3 over 2 if we rationalize it. So now I'm wondering what angle has a y value of radical 3 over 2. And once again, I'm restricted to the right side of the graph. So that would be the angle pi over 3. So if you guys want to try one like that really quick, I'll throw one your way. Try this one here. Arc secant of 2 radical 3 over 3. Okay. Now this is where I'm going to stop this video, and I'm going to actually address the answer to that question in our notes for lesson 2.8. So if you want to see if you did it right, you can check there. All right. Thanks for hanging out with me for the review.